Hello friends, this is lecture number 6 of deep learning, and in this video we will go through 10H activation function. So in lecture number 5 we've gone through sigmoid activation function. You can also go through that video. So let us start with 10H activation function. So what is 10H activation function? 10H activation function is an hyperbolic agent tangent function, and it is non-linear activation function. Okay, the output of the 10H activation function ranges from -1 to 1, while the output of sigmoid activation function range from 0 to 1. So it is widely used in neural network as a non-linear activation in hidden layers. So 10H activation function is mainly used in hidden layers. So you can see in this figure the output ranges from -1 to 1. And the mathematical definition of 10H function is 10H of x is equal to e raised to x plus e raised to minus x upon e raised to x plus e raised to minus x. So here the output ranges from -1 to 1. Yes, it is zero-centered function. The curve shape is it is a S-shaped curve and it is non-linear. So zero-center output helps in faster and more stable learning. Now, what is the mathematical definition? Mathematical definition of 10H is given as e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. So where x is the input to the neuron and e is the neural number and 10H is the activation output. So this function is applied at the neuron level and we'll check whether the output is 0 or 1. So what are the features of 10H function? So let us see the features one by one. So output ranges from -1 to 1. So first feature is the output of 10H lies between -1 to 1. So for a large positive input, the output approaches to +1, and for large negative input, the output approaches to -1. And if the value of x is 0, then output is also 0. So here in this figure, you can see for large positive input, the output is from +1, and for large negative input, the output is -1, and for x is equal to 0, the output is 0. So this is how the 10H function work. Now, next is how to why it is zero-centered function. So 10H is zero-center, which means that output of the output can be positive or negative. But if you take the sigmoid function, in sigmoid the output is 0 or 1. So this is the difference between 10H and activation. Here you can see the output is -1 to 1, and the sigmoid the output ranges from 0 to 1. So this is the biggest difference. So that's why it is known as zero-centered function. Now S-shaped curve. Next feature is S-shaped curve. The 10H function has smooth S-shaped curve. So you can see here it is S-like shape and there is no distraction in the shape. So negative input produce negative output, positive input produces positive output, and the output changes smoothly around 0. So here you can see the output gets changes. So that's why it is smooth curve and it is S-shaped curve. Next feature, saturation at the extreme value. So here for a very large positive and negative value, the 10H becomes saturated. Here it is saturated for large positive value, for large negative value. Here also it is saturated. So that's why there is saturation at the extreme point in 10H function. 10H is zero-centered. Again, it is zero-centered function. That means the output ranges from -1 to 1. For large negative value, output is -1. For large positive value, output is +1. And for 0, the output is 0. The zero center property can make optimize more convenient in some of the neural network. So that's why it is known as zero-centered function. The advantages of 10H function is symmetry around 0. Since the output is centered around 0, the network has better chance of balancing the weight. So that is the biggest advantage, and it makes the algorithm more faster and stable. So improve convergence means algorithm can stop very early, and gradient descent efficiency. So unlike sigmoid, which is constant between 0 to 1, while tanh the range is from -1 to 1, which it helps in faster weight updates during the training. So these are the advantages of tanh function. Disadvantage is vanishing gradient problem. So this is the biggest disadvantage. You can see the tanh suffer from vanishing gradient problem for large value of input. Means for large value of positive value, the output saturated at +1. For large negative value, output saturated at -1. So the value gets saturated at this level. So there is vanishing gradient problem. Then it is not suitable for all type of tasks. When tanh work in some of the cases, but it is not best option in neural network. For instance, the ReLU is more popular as compared to tanh. And next is it is very sensitive to outliers. So here you figure in this figure you can see these are the extreme input. For extreme value the curve gets saturated, so that's why it is very sensitive to outliers. So when to use tanh? When data is normalized or centered around 0, then we can use tanh. So if the data is centered around 0, we can easily use tanh because output ranges from -1 to 1. If you are building shallow neural network, that is neural network having very few layers, then you can use tanh. Or you can working with data where negative value are significant. If negative value are too much, then we can restrict it to -1. So in that case, we can use tanh. So now next is derivative of tanh. How derivative is calculated? ddx of tanh is equal to 1 minus tan square x. So suppose if y is equal to tan h of x, then y dash is equal to 1 minus y square. So if we know y, we can easily calculate the derivative of tan x. So consider, let us say example, numerical example now. Suppose if value of x is 0, then we have to calculate tan of 0, which is nothing but e raised to 0 minus e raised to minus 0 upon e raised to 0 plus e raised to minus 0. So where e raised to 0 is equal to 1. So tan h of 0 is equal to 0. So here it how it is solved. You can see now next is tan h of tan h for x is equal to 1. Again we have to calculate here e raised to 1. So e raised to 1 is 2.718 and e raised to minus 1 is 0.368. Put this value in the formula. So we will get the output tan of 1 is equal to tan h of 1 is equal to 0.7616. So this is how it is calculated for x is equal to 1. Now next is calculate the derivative. First of all, we have here the value of x is 1. So tan of 1 is 0.7616. So tan h dash x is equal to 1 minus tan h square. So it is nothing but 0.4200. So this is how it is calculated. So tan in neural network. Next topic is tan in neural network. So here, how to use tan h? First of all, we have to calculate input. We have to actually multiply weight and input and then add the bias and then apply whatever output, pass it to tan h activation function. So here the W1 X1 and W2 X2 plus bias is calculated. So bias value is -5. X1 is 2, X2 is 3. So it is multiplied. So output of Z is 0.9. Now it is not solved, not yet. Now let's go next. So we have calculated the value of Z. Now pass it to tan H. So Y is equal to tan H of 0.9, which is nothing but 0.7163. And derivative, if you calculate y dash is equal to 1 minus y square. So y dash is equal to 0.4869. So this is how the um, derivative value is calculated. So now next is sigmoid versus tan h. What is the difference between sigmoid and tan h? First of all, the output is ranges from 0 to 1 in sigmoid, while in tan h it is -1 to 1. Here the sigmoid is not zero centered, tan h is zero centered. For x is equal to 0, sigmoid output is 0.5, while tanh output is 0. The curve shape is same again, S shape, and sigmoid is better if there is binary classification, that is 0 or 1. And tanh is used if there is zero centered value or zero centered output. So these are the key differences between tanh and sigmoid function, and sigmoid is already covered in lecture number 5. So I do hope you understand the tanh activation function. So if you like the video, then please subscribe, like and share. Thank you.